Hello students, this is chapter 10, our barren moon. In this we'll learn about the nature of moon's surface, the moon's interior, and moon's origin. First, we want to understand the relative sizes of the Earth and the moon. The diameter of the moon is about 1/4 the size of the Earth, and the distance between the Earth and the moon is 384,400 kilometers. Sometimes this is also described as a distance of 30 Earth diameters. Here are some properties of the moon. The average distance is 384,400 kilometers. The apogee, that is the maximum distance, is 405,500 kilometers, and the minimum distance, which is perigee, is 363,300 kilometers. This variation in the distance is why the moon looks a little bit bigger or smaller sometimes. However, the change in size of the moon is not as huge as sometimes described in the culture and in news. The maximum variation in the size of the moon is 14%. The average orbital speed, the speed with which it moves, is 3,680 kilometers per hour. Sidereal period, time it takes to complete 360 degrees, is 27.322 days. The synodic period, new moon to new moon, is 29.53 days. Inclination of lunar equator to orbit. This is like the Earth is tilted at 23.5 degrees. In the same way, the moon's axis is tilted 6.68 degrees. Inclination of orbit to ecliptic. The orbit of the moon is tilted at 5.15 degrees to the orbit of the Earth. The diameter of the moon is a tiny bit more than a quarter of Earth's diameter. The mass of the moon is 1.23% that of Earth's mass. Average density, 3,344 kilogram per cubic meter. Escape speed, 2.4 kilometers per second. Gravity, 0.17, or variously it is also described as 1/6 of Earth's gravity. Albedo, which is the reflectiveness, how much light it reflects, is 0.11. Incidentally, this is less than the albedo of the Earth. There is extreme variation of temperatures on the moon because of absence of atmosphere. The parts which are getting the sunlight at some point of time, they get very hot, up to 130 degrees Celsius, which is hotter than the temperature of boiling water. And on the dark side, it goes to minus 180 degrees Celsius. It is important to note that the moon doesn't really circle around the Earth, but the combined Earth-Moon system rotates around the combined center of the Earth-Moon system. And that center of the Earth-Moon system is what is moving in an elliptical orbit, in an orbit around the sun. There is some information about lunar libration, which is put there mostly for your interest. Please read them on your own time. However, as far as the questions and tests are concerned, these are the important things. It's a waterless world. There is no liquid water on the moon. There are several reasons. Liquid water cannot exist, and because of absence of the atmosphere, plus the very harsh direct sunlight, the solar radiation, photodissociation occurs, which means that the water molecule breaks up into hydrogen and oxygen. There may have been water at some point of time, and it might exist as ice in permanent shadow areas. When astronauts visit the moon, they wear the spacesuits. What is the purpose of the spacesuits? It's twofold. One is to provide the oxygen, and the second is temperature regulation, because there are such extreme variations of temperature. If we look at the surface of the moon, we can see craters, and we see these dark colored areas, which are called Maria. And then the light colored areas are called lunar highlands. With a with a powerful telescope, we can see lots of craters on the moon. These are the steps of formation of a crater. Usually craters have a central peak, which is like bouncing back after the crater impact. Sometimes if the asteroid is too big, it cracked the surface and caused the lava to flow out and fill the crater, which is what created the mare, the dark colored mares. This is a comparison between the near side of the moon and the far side of the moon. The near side of the moon has much more mare, and later on we'll see much more higher iron content, whereas the far side of the moon has much less mare. Here are some pictures from the missions to the moon. Here is another picture of near side and far side, and the red color shows the iron content. You can see the near side has so much more iron content. This is an internal structure of the moon. It has the crust, the solid upper mantle, the plastic asthenosphere, and the iron-rich core. Its core is much smaller than the Earth. However, the basic parts are the same: crust, mantle, and the core. As you can see, the crust is thin and broken on the near side, and because of that, the iron-rich lava has seeped into the surface. The soil on the moon is called regolith. It is very finely uh, powdered rock. And even though it is not wet, there is no water, it is capable of holding a shape. We talked in chapter 3 how the Earth produces the tidal force, how the moon produces tidal force on the Earth, producing the tides. In the same way, Earth's gravity also produces a tidal force on the moon, stretching it in the direction lining up with the Earth. This has caused the moon to become not completely spherical, not a perfect sphere. And because it is not a perfect sphere, the Earth's gravity acts on it to align it in such a way that one face of the moon always faces the Earth. That's why we only see one side of the moon. The surface, soil, and rocks have been studied. There are 3 types of rocks on the moon. First is called mare basalt. These were produced when the hot lava came to the surface and cooled. It is identified by the many cavities which were formed when the gases were escaping and the lava just cooled and solidified in the middle of that process. Then there is anorthosite. The light-colored lunar highlands are composed of this ancient type of rock, which is thought to be material of the original lunar crust. And then there's impact breccias. When the asteroids hit hit the surface of the moon, they create huge amounts of heat, and that causes the material to melt and solidify. These are called impact breccias. Here is a graph showing the rate of crater making impacts. As you can see, 4.5 billion years ago is when the solar system was made, and it was much more chaotic and full of lots of planetesimals and debris and asteroids. And so the rate of impact was very high. Then it dropped, and then it rose again around 4 billion years ago. And since then, the rate of asteroid hits is getting smaller and smaller. And currently, the rate is 1/10,000th as great as the most intense bombardment. There is an interaction between the tides and the moon. The tides on the earth, tides produced on the earth, also apply a gravitational force on the moon, causing it to move faster in its orbit around the earth. This causes the moon to gain energy and to slowly spiral out, get away from the earth every year, although this process is very, very slow, but it is significant and adds up. And it is predicted that after thousands and millions of years, moon will be quite far away, and therefore it will look small to us, and it will stop having total solar eclipses, because the smaller angular size of the moon will not be able to cover the disk of the sun. Now, the last topic is how the moon was formed. It is thought that the moon was formed because a Mars-sized object named Theia impacted the Earth, and that is what caused the Earth's axis to be tilted. And it also broke off a chunk of molten material from the early Earth. That material went into orbit around the Earth and then coalesced to form the moon. So this is the current theory of the moon, of the origin of the moon. And with that, this chapter is over.